Hello students, in this video we'll discuss about access to non-local data on the stack and also parameter passing. So in the last video we have discussed about storage organization, how the storage is organized into 5 sections like code area, static area, stack area, heap area and free memory. But what kind of data will be stored in which memory, so that we'll discuss in this video. See, storage allocation is done for two types of data. One is local data and another one is non-local data. What does it mean by local and non-local? See, whenever in any programming language where it allows the flower brackets, this starting of flower brackets is nothing but starting of a new scope or block, and its corresponding ending flower brackets is the end of a block. So if you declare a variable here like int a equivalent to 10, then we can say that this a is local to this block. And if you declare a variable like this int b equivalent to 20, then this b, for example, if you are writing here print a and also b, assume that, then this a is inside the block, then we can call it as local, and this b is not inside the block, then we can call it as non-local. Then how these non-local data are going to be accessed? So in the main memory and where it is going to be stored, so that we'll discuss. See, when this, where the programming languages are not supporting the nesting of procedures, like a procedure inside the another procedure, this is called nesting of blocks or procedures. See, where you are having the nesting of procedures, how these non-local data will be accessed, and where it doesn't support this nesting, how they are going to be supported. First, in C like languages where it is not supporting the nesting of procedures, but a procedure calls another procedure, that is allowed, but writing a procedure inside another procedure is not allowed. In that case, all the non-local data will be stored as a global variables and it is occupied in the static storage, and we are coming to know about that at the time of compilation. And where it supports the nesting of blocks, there we are going to follow two rules. One is static scope and dynamic scope. So static scope is only for block structured languages and dynamic scope is used in non-block structured languages. What it is, we'll discuss. First, how we are going to access the non-local names. See, we have two scopes as we have discussed previously, that is lexical scope and dynamic scope. So static scope means the name should be determined at the time of compilation, and always it go for the most closely nested rule. I mean say that, for example, we have a block 1 and we have a block 2 and we have a block 3. Assume that, and the nesting of procedures are not allowed, but we can call one function from another function, right? Like we are calling from the block 3 we are calling block 1 and block 2. So then what will be happen, for example, if you have a variable here, then if you are accessing a variable, if search for the local, if not it will go for its nearest parent, if not, if it is called by some other like that, it will take it. Then in dynamic scope we are going to decide at the time of execution, right? So in lexical scope, how it is going to be happen, see every block is having its own activation record. Like you are calling a procedure begin and end blocks, then that will be treated as its activation record, it will search for it. If there is no value in its activation record, then it will go for its parent function who is calling it. So by using the access link, here access link maintains information about the parent activation record, right? Or sometimes we may use the displays. So then we'll discuss with an example. Assume that we are having 4 procedures, guys. One is main, right, and another one is Q, P and S. Okay, so in the main we are having 3 procedures, but directly we are having only 2 procedures. In main we are declaring P and we are declaring Q, right? So in Q we have a nested procedure called S. Within the Q we have a nested procedure. So actually the program starts from main here. So main activation record will be created. Then main is calling what? Q. So the Q access link will be pointing to the main. So then if in Q1 or in Q, so first we are calling the Q with 1, that's why we have taken here. Then the Q function begin here. If I is greater than 0, of course, yes, because we are 1, then we are calling Q of 0. If I is 1, then we are again Q of 0. So then again it will maintain the information about its parent and also its super parent. So if the value is here, then well and good, otherwise it will go for the grandparent, we can say that. So this how it is going to maintain access link. Then if it is 0, then we are calling what? S. So is called by the S. If Q, we are calling Q with 0, then this condition is false, then we are calling S. So S is called by the Q0, not by Q1, it is called by Q0. Then once it is end, we are going to call what? P. So who is going to call the P? So the Q in its beginning it is calling the P, right? So then the P is actually accessing which value here? A. Then P is calling A equivalent to N, right? So we are calling A. B is actually called by whom? Q, but we don't have A. Then Q0 is called by whom? Q1, but we don't have A. And Q1 is called by whom? Main. We have A. So the P should access the A value from the main. Like that we have to establish the links. We have declared a where we are using a value A, but from where we are using it? From which activation record we are accessing? So we have to maintain the link. Okay. So even though the P was called by the Q, but we have to maintain the link to main as we are accessing the non-local data from the main. Then we have a display. So instead of maintaining the callee and call, we are going to maintain the all activation records as a array. So that we can call it as display. So first activation record, when the who is calling this, so the first activation record at level 2, level 1, level 2, level 3. So based on the non-local data, even though for example A is calling B, B is calling C, C is calling D, but assume that this activation record 1, 2, 3, 4. Assume that the D is accessing the non-local variables from the A. So then we can directly pointing to this display. So the D has to point to this. Means what? Assume that this is a fourth block, right? So even though the fourth one is called by the 3, but we have to maintain the access link to 1 as we are calling the non-local variables from the 1. Right? So that is in block structured. In non-block structured, right? So we are going to use the deep access or shallow access. What does it mean by deep access or shallow access? In the non-block structured languages, see, we are going to have a stack like an activation record is maintained by another activation record and maintained by another activation record like this. Okay. So when we don't have another one like the deep access displays, then what will happen in the deep access? If you don't have it, then you have to go in depth of the stack. You search here. If not, go search here. If not, go search here. If not, go search here. Because I don't know at the compile time how many activation records are going to be created. Right. So that's why you have to go deeper to the stack. That's why we are calling it as deep access. So what does it mean by shallow access? So assume that we are having a activation record, one is calling another and one is controlled by another or one is calling another like this. Then for every activation record we are going to have a central memory. So there all these values will be stored for every activation record, whatever the local variable that are maintained here. So by using this central allocation, we can access the non-local values. So that is about accessing non-local data from the different languages and different kinds of programming language like block structured and non-blocker. And how we have a next concept called parameter processing. See, we are having functions like this, for example, main. Okay, so then we can call a function like add. So a comma b. Then we have a function definition add int add. So int x comma int y. So we are having like this. See here the main is calling another function called add. So with different two parameters. So these are called as parameters, and xi y also called as parameters. The parameters what we are using in defining a function, they are called as formal parameters. They are formally used, right? Formally used. And these are the actual parameters where it is having the values, like assume that a equivalent to 10, b equivalent to 20. These are the actual parameters. These are formal parameters. See, based on this, what we are sending to the definition of the function, we can divide this parameter passing into four categories. We have so many. Yes, we are discussing four here. First one, call by value. See guys, here 10 and 20. So we are simply sending this a. What is the value of a here? 10. What is the value of b here? 20. So that will be stored in the x, 10 and 20. And if I write here x plus plus and y plus plus, so that will not be affected into the main function. So if I print here x and y, the value will be 11 and 21. But if I print after completion of it, the value is 10 and 20. Whatever you changed here, that will not be affected here. But in call by reference, where you are sending the address of it. For example, the address of A is 1000 and address of B is 2000. Then we are sending to the star pointer, we are sending the address. So this X now is pointing to the A only, and the Y is pointing to the A. So if I write here star X plus and star Y plus plus, it is going to be changed in the A to 11 and 21. So this is called call by reference. We are sending the address instead of values. Right? And what does it mean by copy and restore? So this is a variant of call by value where it is going to use both the call by value and call by reference. How it is going to be. So guys, listen here. See, if you have a function called like this main, okay, I am calling here int a equivalent to 10, and we are calling add of a. Okay, so by using copy and restore, actually C doesn't support this, but let me explain. So add int x, right? So then what will be happened here, guys? Listen here. So now a, what is the value of a here? 10. So that will be sent. A value is 10. That will be sent here. Then if I change here, right? X equivalent to 10 plus 20. So the x value will be changed to 30, but still a is 10 only. So assume that this a is a global variable. Then if I write a equivalent to 15, now the value of a is 15. Assume that a is declared as a global variable. Okay, so assume that a is 0 here. What is the a value? 10, change to 10. Then what will happen? X is 30, a is 15. So the global variable of a will be changed to 15. Then when you return this function add, what will be happen? So this a is actually stored given to which one? X. Then whenever this function is returned, whatever the current value of x will be changed to a. Means what is the current value of x? 30 will be restored to the a. Right. So now here until the function is returned, the value is changed, right? The value won't be affected here. And if it is a, you can take this 0 or 10. But when the function is called and we changed a to 15, but this won't be affected. Why? Means when we restored the current value of x, which will be restored to the name. That's the meaning of it. And the final one, call by name. So here the call by name means it's just an inline expansion, macro expansion. Here what is we are calling here, right? Okay, let me go with this. So here a we are calling, then what will happen? This name will be replaced here, changed to a instead of x. So wherever you are having a, that will be changed to x, that will be changed to a. For example, if you are calling the same add function with the b, then this x will be changed to b. Just the macro expansion. The names will be replaced instead of only values, even it can change the names also. So in the next video, we'll discuss about heap management and garbage collection.